All right, so we just got done graphing absolute value functions, which form that V shape and doing transformations with them. We're going to look at a new kind of function. We're going to look at, this is called a quadratic function. This has been a while. If you remember, we talked about if you have x raised to the second power, if 2 is your highest power, we call it a quadratic. So quadratic. So we want to first of all just figure out what this looks like. So we've done linear functions, right? They form a straight line. We've done absolute values that form that V shape. We want to find out what a quadratic looks like. So the easiest way to do that is just by making a table. So go ahead, make an XY table underneath here. And let's pick some values for X and plug them in and see what we get for Y. I'm going to try both some negative and positive values. So I think I will do, let's go from -3 to +3. Okay, so take -3 and plug it in here. Be really careful when you do that. It looks like this, y equals -3 squared. Well, -3 squared means -3 times -3, which comes out to be a +9. Plug in -2. So if we made that a -2 right there, -2 squared would be a +4. If you plug in -1, right, -1 times -1 comes out to be a +1. Plug in 0, 0 squared 0. Plug in 1, 1 squared is 1. Plug in 2, 2 squared is 4. Plug in 3, 3 squared is 9. Okay, let's take those points and graph them and see if we can get an idea of what this graph looks like. So I've got -3, 9. So that's just off my graph. It's right up there. I have -2, 4. I have -1, 1, 0, 0, 1, 1, 2, 4. And then 3, 9. So it kind of looks like those, like the absolute value of the V shape. The difference between this one is this does not form straight, the sides are not straight, the sides are curving. Okay, so it comes down like this. And it looks something, kind of missed my point there, but it looks something like that. The sides are constantly curving. Okay, what I want you to do is pause the video, and I want you to write down 3 observations or characteristics you can think about this graph, and then come back and I'll go through some of the observations I can see. So kind of what you're thinking of is what makes this graph unique or different from other graphs. Okay, so here's some of the observations I would see. First of all, it has a vertex like the absolute value equations. So label that center point. Where the function stops going down, it stops decreasing, and it starts to increase the opposite direction. In this case, it's the low point on the graph. You'll see in a minute that if we flip it upside down, it could also be the high point. Something else, like the absolute value function, it's symmetric. So let's write that off to the side. So the graph is symmetric. In this case, it's symmetric about the y-axis. Remember, that just means if I fold it in half, the 2 sides would match up perfectly. One thing I want you to make a note of is put this down. It's what we call a smooth curve. That means there's no sharp turns. Okay, it's changing. It's constantly changing and curving. Okay, so it's a smooth curve as we work around there. So we got the vertex, we got symmetric, we got the smooth curve. One thing that's helpful in describing the graph is the domain and range. So let's put down both the domain and range. So our domain is the x value. So if you're picturing like how far to the right and left does this graph go? Well, the graph keeps going left forever and it keeps going right forever. So the domain is -infinity to infinity. And in the range, the way I picture that is think of there being, I'd grab your pencil. I'll make that red line right there is going to be my pencil. You're going to run it up the graph. Start from the bottom and go up. So there is no graph down here. And as I go up, if it will let me here, the graph does not start until I get to right there. So you're looking on the y-axis. So what is my y value right there? And my y value is 0. So I'm going to do a bracket 0. And then how far up does it go? So as I run that up, well, that graph keeps going up forever. So it goes from 0 to infinity. So the range you'll see, the domain and range, and we'll go through some examples here where we find that. You should see that it's a lot like the absolute value function. Domain is always going to be -infinity to infinity. With the range, you're going to look at where the vertex is. Okay, where is that on the y-axis? And that will help us to determine what the range is. Okay, so that's our goal for the day. We want to be able to graph quadratic functions. Now we're going to do this using transformations. So we're not going to make a table every time. We're actually going to do some transformations and find what the graph looks like. To do that, we're going to use another decimals calculator, similar to what we did on the last one. So if you want to pause the video, go to this website, pull up the decimals, and then come back and we'll kind of go through and do these transformations. All right. So this is what it should look like right here. We'll refer back to this as we go through this. Okay, so like before, if you look up here, we're going to figure out what happens as I change that inside number h, what happens as I change the outside number k, and what happens as I change that number I'm multiplying by, that a in front. So we're going to mess around with all three of those and kind of see what happens. If you look at your next slide on your note page, should have this. So we want to compare, what does y equals x squared look like? We know what it looks like. We want to find out what does y equals x squared plus 2 look like. So we're adding 2 on the outside. So if you go back to that decimals calculator that we just had up here, what we're changing is we're adding on the outside, we're changing k. So come down here, and we're going to select k. We want to change it to 2. And what we should see is just like it did with the absolute value, is when I added 2 on the outside, it took the graph and shifted it up 2. So go back to your notes page and let's draw a sketch of what that looks like. So instead of the vertex being at 0, 0, when I added 2 on the outside, it shifted the vertex up 2. So that's where my vertex is now. Now nothing else changes about the shape. So notice on my, oh, by the way, I'm sorry, I need to go back here. Go back to your graph. These quadratic graphs have a special name. They are referred to as a parabola. So a parabola. So that U curvy shape right there, we refer to as a parabola. It's a graph of a quadratic. Okay, so we're back here. So we're going to go up 2, that's where my vertex is. And then if you notice on the original graph, right, I go over 1 and up 1, and over 1 and up 1 on either side. We do the exact same thing. So I go over 1, up 1, there's a point there. Over 1, up 1, there's a point there. Now, you cannot keep going over up 1, because watch what happens on here. On the next point, I go over 2 and up 1, 2, 3, 4. So from this point, I go over 2 and up 1, 2, 3, 4. It's getting steeper. There's a point on the other side. I just want you, those 3 points are great. So if you just did those 3 points, okay, that's enough right there to show what the graph looks like. So it should look just like the original, the y equals x squared, which is already graphed here. The only difference is it shifted up 2 from where we were at. Oh, by the way, hopefully we can make this prediction, right? If I took y equals x squared minus 3, right, all that's going to do is take the graph and shift it down 3. So if you add or subtract on the outside, it moves the graph up and down, just like it did with absolute values. Okay, now let's try adding or subtracting on the inside. This is a little tricky with your graph, so make sure you're following along here. So we got x minus 2 squared. So if you look up here, now instead of changing what k is, we're going to change what h is. Now notice how the x minus is already there. So if I want x minus 2, I'm actually going to change h to 2. So I'm going to switch k back to 0. By the way, look how k changes, right? Positive up, negative down. Now this is a little tricky with h because the formula already has the minus in there. So watch what happens. I want to go over to where h is 2 to get x minus 2. So you'll see what happens to the graph there. When it was x minus 2, it's just shifted to the right 2. So let's go back again to our graph right here, and let's draw what it looks like. So if it's a minus 2, it's just like before, where if it's inside with the x, it moves it left and right, but it goes the opposite way. If it's a minus 2, it actually shifts it to the right 2. So instead of my vertex being at 0, 0, now it's shifted to the right 2, it's right there. From there, just do your graph. We know we go over 1, up 1 on either side. Then if I go over 2, right, 2 squared is 4. 1, 2, 3, 4. And I can go left 2. Negative 2 squared is also 4. So it's always going to be over 1, up 1, over 2 up 4, as long as we haven't changed how steep the graph is. So my graph looks like that. So same shape, it's just shifted right 2. If I were to do this, y equals x plus 4 squared. So you got to remember, inside with the x moves it left and right, just like the absolute value. But the plus 4, right, you don't trust the x, you go the opposite direction. So we're going to go left 4. So this one, the vertex would be shifted left 4, it would be right there. And then from there, I go over 1, up 1 for the next 2 points. And then I go over 2, and 2 squared is 4. So over 2, up 4, left 2, up 4. And there's my parabola. That's if I add. So that's the trickiest one, right? If you're subtracting on the inside, it moves it to the right. If you're adding on the inside, it moves it to the left. Okay, the last transformation is what happens if I times. So now I'm not adding 2, I'm timesing by 2. So y equals 2 times x squared. So let's go back to our decimals graph right here. And now we're not adding or subtracting on the inside or outside. We're timesing by a number. We've got that number out in front. So I'm going to switch that h back to 0. And now I'm going to change what a is. So on that example, a was 2. So we're timesing by 2. So if I times by 2, it looks like that. So you can see what happened to the graph, right? The bigger a gets, the steeper the graph gets. Remember, we call that a vertical stretch. The smaller a gets, the wider it gets. If a is negative, instead of opening up, it opens down. And again, it becomes a greater and greater. It becomes the absolute value of a becomes bigger. It makes it steeper. So you see what happens at -4. So now notice how the vertex doesn't change. A does not change where the vertex is. It simply changes how steep it is, and it controls whether it opens up or it opens down. So again, let's go back to our original graph right here. So if a is 2, here's what's going to happen. My vertex doesn't move. It's still there in the center. But all I do is I times all my y's by 2. And this is what I mean. Normally I go over 1, up 1. Well, now I go over 1. Instead of going up 1, I go up 2. So over 1, up 2. The next point, normally I go over 2 and up 4. 2, 3, 4. Well, on this new graph, I go over 2. Instead of going up 4, I double that. I go up 8, right? Because I'm timesing by 2, right? Timesing by 2 over here. So I go over 2, up 8. That'd be all the way up there. There's another point on the other side. So it stretches the graph vertically. It makes it steeper. So I don't care if you think of that as being steeper or if you think of that as being a stretch, a vertical stretch. You can describe that either way, but that's what's going to happen. If I were to make that a half, let's do that a different color. So I'm going to do that blue. So if I were to make it y equals a half x squared, if that number is less than 1, this has a 1 out in front of it. If this number is less than 1, it makes it steeper. So what's going to happen on this one is I'm going to go over 1, and instead of going up 1, I'm going to go up a half on either side. And then normally I'd go over 2 and up 4. Well, I'm going to do half of that, so I'm going to go over 2 and up 2. So if you look what happens to that graph, it ends up looking, oops, I went over 3, sorry, over 2. It ends up looking like this. It's like flattened. And that's constantly curving, so that would be a half right there. If you make it a negative, y equals a negative x squared. So we do that even a different color actually. So let's do that we'll do it in black. I do y equals a negative x squared. If you make that a negative, it just makes it open down. So my vertex hasn't moved, right? I'm not adding or subtracting. It hasn't moved. But now instead of going over 1, up 1, I go over 1, down 1. So it's going to be coming down that direction. So again, go back to that grapher one more time here, and you can kind of see what happens as you move up and down, as you change what a is, right? So you can see what a is. It's negative, so it's going down, but it's getting closer to 0, so it's flattening out. And then as soon as it becomes positive, now it's going up. Kind of a cool thing, if you hit the play button, all these, it will change that, right? So that you can see what happens as a gets bigger, and now it's getting smaller, right? You can see how it's widening out. If it becomes negative, it's opening down. We can change h. Now we're going to move it left and right. We can change k. Now we're going to move it up and down. So you can get all those different transformations going, changing to ah and k. Here's the really nice thing with all of those is that they're exactly the same as the absolute value. So if the absolute value problem made sense, this one hopefully should also make sense. So just to make a summary, the K moves the graph up or down. So I call that a vertical translation. You're just moving it up and down. So plus up, minus down. H moves the graph left or right. Left and right is on the x-axis, right? It's with the x, inside with the x. The tricky thing is don't trust the x, do the opposite. So if it's a plus, you're going to go left. If it's a minus, you're going to go right. And then A controls how steep the graph is, and it also controls whether it opens up or down. Right? Positive up, negative, it opens down. So these are exactly the same as the absolute value. The only difference is instead of doing it with the V, you're now doing it with the parabola. Let's do a couple of examples. So if I give you this graph, y equals x minus 3 squared plus 1, I want to draw a sketch of what it looks like. First of all, the square right there, you never do anything with that. That's what makes it a parabola. That's what makes it a quadratic. So we know what shape it's going to be. It's going to be that parabola shape. Okay, now I'd always start by finding the vertex. Normally the vertex is at 0, 0, right? But I have a minus 3 on the inside. That moves it left or right, and you go the opposite way. It's a minus 3, so I'm going to go right 3. And there's a plus 1, so I'm going to go up 1. So my vertex, and I want you to write this off to the side, the vertex is at 3, 1. Right? The 3 came from in there, right 3. The 1 came from right there. Okay, and then I look at what A is. If there's nothing there, it's just a positive 1. So this is just the normal graph. I go over 1 and up 1, over 1 and up 1, and then I go over 2 and up 4. So if you remember that rule, over 1, up 1, over 2, up 4, it'll make it easy. 1, 2, 3, 4, from the vertex. Okay, then draw my parabola. Okay, and I'm done. So left, right, up, down, find where the vertex is. Okay, and then A determines if it's opening up or down, and if it's steeper or less steeper, in this case, just normal. Okay, let's do the domain and range. You'll be asked to do that on your assignment. So the domain is your x values. Well, this graph keeps going out left and right. I can go left and right forever, so it covers the entire x-axis. The range does not. So remember, pick your horizontal line, your pencil or whatever, you're running it up your paper. It doesn't start and graphs start till right there. Be careful, it's not the x value, it's the y value. So what is y when my line hits there? Y is 1, right? It's always this, it's the y coordinate of your vertex. So it's going to go 1 to infinity, and I got it. So here's my domain and my range. Okay, let's do this one. So my function is y equals negative x minus 2 squared plus 3. I always start by finding the vertex. So that moves it right 2, and that moves it up 3. So I'm going right 2 and up 3. That puts my vertex right there. Let's write that down. The vertex is right 2, up 3. By the way, there it is right there. There's my right 2, comes from that. My up 3 comes from that. Okay, now A. A is a negative 1. There's a negative 1 in front. That means it's opening down because it's negative, but we haven't stretched it. We haven't made it steeper. So I just go over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4. So that is what my graph looks like right there. Let's try one more. This one's got a 2 in front of it, so you can kind of see a stretch here. Okay, start by identifying the vertex. So again, that's the pluses and the minuses. So I've got to go right 1, so positive 1, and I've got to go up 1, also a positive 1. So we're going to go over 1, up 1. That's where my vertex is. I've got a 2 in front. That changes things. It's going to be positive, so it's going up, and the 2 is also going to stretch it. And what I mean by stretch it is normally I go over 1, up 1. I got to go over 1, up 2. I got to times it by 2. Normally I go over 2 and up 4, but I'm timesing by 2, so I go over 2, up 8. So 1, 2, 3, 4, 5, 6, 7, 8. From the vertex, over 2. And really, if you know where this point is, remember we said it was symmetric. Think of that line down the middle. It's just got to be straight across from that. Okay, so draw your parabola, and you can see how it's narrower because it's steeper. It's going up faster. Okay, so those are your big things. Find the vertex first. So look at the adding and subtracting. If you add or subtract on the inside, moves it right or left. Outside moves it up or down. So identify where the vertex is. And then you look at what the number out in front is, A is, to determine whether it's opening up or whether it's opening down, and also whether it's steeper or less steep. Oh, domain and range. Hey, let's do that real fast. I'm sorry, before we end. Just so you can see another practice. Domain will never change. On every single problem, if it's a parabola, it opens out both ways. It's got to be negative infinity to infinity, but the range is not. So do your horizontal line. As I go up, it starts at 1 and goes to infinity. Hey, let's go back to the last problem. Sorry, I forgot domain and range on here. Let's do the domain and range on this one. Domain, range. Okay, this is a little bit trickier. When I grab my pencil or whatever and I do my horizontal line as I run up, the graph goes down forever. So if I say where does it start on the bottom, it starts at negative infinity. Now where does it end at? It goes all the way until I get to there, and I'm looking at the y value over here. So it ends at 3. And again, notice how that's just the y value of the vertex. So make sure you're finding domain and range. Again, that is really, really similar to what we did with absolute values. All right, good luck. Let me know if you have questions.